So my name is Adrian Velazquez. I work for CP Group, CP Manufacturing. We design, engineer, and build and install material recovery facilities for the recycling industry. I'm the engineering development manager there. I have Jason Kerns with me. He's our SolidWorks administrator / developer. So the agenda for today, have a little disclaimer, just kind of take the presentation with a grain of salt. We're going to talk a little bit about our projects, our extra large assemblies, hardware considerations and options, do's and don'ts for SolidWorks, some additional tips, tools and tips to help you work in this size assemblies, some SolidWorks setting options, and a little bit on drawings, or not drawings. So disclaimer, like I said, take this presentation with a grain of salt. A lot of the content, a lot of what you will see will not necessarily apply directly or kind of to your environment. So it's not a SolidWorks 101. There's some shortcuts and workarounds that we do. So you got to think outside the book. That's kind of how I put it. Some of the recommendation has to do with us having EPDM. So the whole change state and check in, check out, that plays into why we do certain things. Assumptions that you are looking into investing in hardware or have decent hardware. This is for, we work at a very high space environment, like the assembly in the project you were looking at, that's about an 8-month project from like when sales is completed to when it's actually running. So we work at a really fast pace. We don't have an actual, I mean, I know the description said 200,000 component assembly, but that's kind of the total BOM item for that project. We don't actually have I mean, we have large assemblies, but not 200,000 yet. And we haven't tried out 2014 yet. So about us, we, like I said, engineer, manufacture, install material recovery facilities. We have plans for curbside pickup, what you would normally have in your blue bins at home, commercial, waste to energy plants, and more. We have over 400 facilities worldwide. Typical engineering schedule is between 8 to 12 weeks of engineering time. And we do all of the engineering for those projects. I'd say projects, 90% of the project we do ourselves in SolidWorks. And we have between 6 to 10 engineers working in one project at once. So this is one of our assemblies, and that's kind of the real thing after this is from last year. So this is the one we'll be reviewing today in SolidWorks. So some more of our projects. This is the largest one we have right now in SolidWorks. The total BOM items is around 185,000. Total number of components for this SolidWorks assembly was around 90,000. So some simplification and configurations and all. That's kind of what we were going to be covering today. So that project is also running. And this one, the one we'll be talking about today, the top level file size for this assembly, this is a SolidWorks photo view rendering. It's 204 megabytes. The loaded in memory assembly when it's running, it's 7.7 gigabytes. Opening time, about 15 minutes. Save time, about 2 minutes. Total number of components in SolidWorks is 69,000. And the deep rebuild time is about 7.5 minutes. If you guys have any questions at any time, feel free to raise your hand, please. There's a lot to cover, so I'll try to skim through this part. Another one of our projects, 39,000 components, almost 40,000. Okay, so to get started, hardware. Yes, you guys will need to invest money. I know when we kind of started moving into SolidWorks from 2D, that was the biggest challenge, getting management and IT to understand that we had special requirements for the type of work that we were doing. So there'll be investment required. It's all about the CPU. I know a lot of people think graphics, I mean, it's a large assembly, a lot of components. SolidWorks is still 90% CPU. If you spend a lot of your money on your graphics card and not on the CPU, you'll have quite some trouble getting performance out of your graphics card if you don't have the CPU that kind of does most of the heavy loading. The memory, I mean, it depends on the file set that you guys deal with. My advice is always go with twice of what your max assembly is, because if you're going to be doing renderings, if you, let's say you have a 10 gig assembly open in SolidWorks, if you're going to render that in PhotoView, as soon as you send it to PhotoView, it actually doubles the memory. It sends the same information to PhotoView, so you end up with that assembly in PhotoView around 20 gigs, a little bit less than that. So like I say, don't overspend on your graphics card. Put all your money on the CPU. We'll definitely need to overclock when we're dealing with this massive size assemblies. Your typical out-of-the-shelf computer for most manufacturers won't cut it. I'll show you what we're working with. So this is the performance benchmark for our typical workstation. Is about 53 seconds or 54 seconds overall. And yes. So what we used, we originally, after struggling with Dell Precision workstations for a while, we went with box, and with pretty impressive results with the box configuration. After a couple of those, our IT department kind of asked us, hey, does the box workstation have anything that's specific to them? It's like, no, they pretty much just assemble it and put a guarantee on it. So they went ahead and took the challenge of building our own custom workstations. And we have been running custom workstations for the last year, pretty stable. We have overclocked Core i7s on them, liquid cooled. We have between 32 and 64 gigabytes of RAM, and we use NVIDIA's K2000, which is kind of their entry or mid-level card. Yes?
What's the clock speed on average on your overclock?
4.7.
It's between 4.3 and 4.7. I mean, they do some benchmarking and testing before they release it to engineering, and depending on stability, it's between 4.3 and 4.7 overclock.
Great, thank you.
Yes.
What's the cost savings off the box? Is building, when the IT department built it, what was the savings off the box?
Yeah, similar spec workstation was about between $1,000 and $1,200 of savings. So when we were talking 10 to 15 workstations, they kind of did the math, like we might as well just do it. And they've been running pretty stable. So I'm happy with them taking that.
Are your custom builds all identical?
No, that's part of the problem. I mean, the first bunch they did, or the first batch, they were pretty stable and they were working good. And it's like, oh, we can make them a little bit better or cut a little bit on the budget. And they were not as stable. So if you come out with a solution that's stable and steady and performs well, I recommend you stick to it.
We've got similarly built custom boxes in-house, overclocked just the same, liquid cooled just the same, and we haven't been able to get them down that low. We're 4.5 gigahertz overclock on an i7, and the closest we can get is like 63.
Okay.
Performance test. So I'd be interested in knowing specifically what components you guys.
Yeah, I can give you guys. I have an actual thread on the SolidWorks forums about our build, and it has the actual line-by-line item of what they bought.
And then will these slides be available?
Yes, I think when they upload the presentation videos, they upload the slideshow as well. And I have my card here, so after, if you guys want to contact me, feel free, or find me on LinkedIn. I don't have a problem with you guys asking. So liquid cool, I mean, that's kind of out there. A lot of people say there's enough good cooling that's air cooled that could kind of manage the overclocking. So I mean, that's up to you. But overclocking is the kind of the highlight here.
Are you liquid cooling just the CPU or the memory and everything else?
No, we're not cooling the memory at all. Well, I mean, just the standard fan that comes with the chassis.
The closed system.
Yeah.
Yeah, that's what I use.
Okay. So getting down to working with large assemblies, we have some think outside the book, why some of the SolidWorks functionality and features help and some doesn't. Isometric. So I'm remoted right now to one of those workstations at the office. We're here in San Diego, by the way, so nothing too crazy. But this is fully resolved. I mean, like you said, I mean, you won't be able to rotate. I mean, you can work on it. It's pretty manageable, following some of what we will be discussing today. So let me run the assembly expert. This is the one that's about 70,000 components as it is, with some simplification and some shortcuts.
Do you use configurations to simplify some of the pieces for the assembly mode?
That's what I will talk about on this slide. So what we consider the do's, what we recommend is use sub-assemblies, of course. That is SolidWorks 101. And we recommend you guys fix components whenever you have a scenario where you can fix a sub-assembly or a component versus mating it. That's definitely something that's going to give you results and performance. Simplify sub-assemblies, simplify parts. Use the defeature command if it works for you. Display states, absolutely recommend it, especially like if you're working with a team and then they're working in a specific area or a specific assignment within your large assembly. Make sure you create display states for them so that whenever they need to go to that top level, they can go straight to just that area and they don't get bombarded with all the data they don't need. Large design review is kind of the same thing. With selective open, use large design review, and we'll be trying to open something in large design review. I mean, I'm not going to be doing too much show and tell because of the performance. I don't want to. That's why I'm remoted into our workstation. The large assembly mode, that's kind of on the fence. What we like to do is to spend automatic rebuild, turn the edges off, and hide the old types. We do that separately. We don't just kind of turn on large assembly mode. We just say individually when you're in your model, you can kind of do those things. So I'll show you. Okay. So the suspend automatic rebuild, if you right click on your top level, that's an option that's by itself right here. So without going to large assembly mode, you can do this. The turn the edges off right here, that's actually, I don't know, probably you guys are familiar with it, but that's probably the biggest bang for the buck when it comes to SolidWorks performance. If you're used to working with edges, that's going to give you the most dramatic improvement, like a click away.
Do you see problems with users being able to actually use the program in that mode? Because a lot of shapes are nearly impossible to visualize without edges.
That's why I recommend display states and selective open, because if what you're working on, you need edges, but it's only like a part of your main or top level assembly, that when you're in on a display state, smaller or less components shown, you can turn edges off, no problem. I mean, I can turn them off for this. This will still work, but that's kind of the biggest improvement as far as performance right away.
Friendly.
Yeah. So, and the other one is hide all types. That's under the view toolbar, and it's right here. So that should also turn off all your planes, sketches, anything that's there that a lot of times you don't see it, but it's still there, especially like points or sketches out in space. If you turn that off or check that box, the hide all types, that improves performance. And that's pretty much what the large assembly mode does. But we like to have more control of it because the large assembly mode has some other configuration aspects that we have noticed that cause issues when it comes to troubleshooting or when it comes to references. So we kind of try to work with those options independently. Oops.
Why were you on the fence about those speed packs?
So SpeedPack is really nice. It works very well. The problem and why we don't use it as much is because we do a lot of simplification of our parts. So our assemblies, we save them as part files. With SpeedPack, you keep the assembly. The problem with keeping the assembly, if you're working with enterprise PDM, every time you do a check-in, a check-out, change state of that tile level, it reads all the references. So you may have a machine in your layout, like in our example, that's 20,000 components. And if I do a check-in of my top level at the end of the day, just to kind of track progress, whenever I get the dialog, it reads all those 20,000 references and their drawings, and if they're configured and have more than one drawings attached to one part model or one assembly, every time you do a check-in, check-out, change state, it'll still read those references. We really don't care for the references. That's a product that's kind of off the shelf. It's set, it's established product. So when we're working on a project and we use that product, we kind of disconnect it by saving it as a part. So that's why SpeedPack works nice, but that's kind of our drawback and why we really don't use it that much. We go more with the simplifying assemblies. Configurations, like you were asking, the reason we don't try to stay away with them, we do more display states for performance reasons, because if you do a configuration, even if you simplify,
You still have the geometry.
well, no, not just the geometry, but you double the size. Most of the time you double the size of that file. So a lot of times you do the configuration to save performance, and it will work at the model level, but when it comes to file size, it doubles the size. So if you end up doubling the size of all your files, I mean, that kind of adds up in memory requirements. It works, but it has its drawback. Yeah.
On SpeedPack, have you guys actually attempted to use SpeedPack and produce drawings? Have you been successful creating?
That's one of the other drawbacks of it. We haven't been too happy with drawings for SpeedPacks, and then
Cut sections through.
yeah, we do, like for these projects. Let me show you this again.
We've had similar issues with 20, 30,000 part assemblies. Plus, we have to check ours into a PLM system, so everything has to be resolved when we check it in.
Yeah, so we do installation drawings in phases of this project. So if we do put a lot of SpeedPack geometry in those sub-assemblies, when it comes time to do the drawings, you run into a lot of issues. So we leave a lot of geometry fully resolved or simplified. So just a little bit more about just kind of dissecting this assembly. We don't have a lot of components on this level. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have about 15, 16 assemblies, and most of the work is done inside those assemblies. This is more like an overall reference of the project. We don't do a lot of work at this level. And that's kind of what you want to do. You want to work, kind of break it down.
So quick question about,
Yes.
Did you make those in place and then fix them and then delete the mates? Or did you kind of reference a common origin inside each of those?
That's one of the next slides. I'll talk about that, about mates.
On the configuration, do you tabulate your drawings? And
No.
therefore have a lot of configurations for...
We have our parts. We do a lot of automation of our products. So let's say a conveyor, like, I don't know, one of these conveyors, we have a certain amount of possible iterations of it. So we have those automated via configurations. So we do use configurations at the engineering level of releasing to production, but for managing the project, we kind of try to stay away from them because of the file size.
How do you stay away from it?
I'll show you.
Okay.
Okay, so the don'ts, lightweight. I mean, when you start using, if you start using everything we talk about on the do's and maybe some of the what's on the fence, lightweight kind of doesn't make sense anymore. We have discovered a lot of issues with referencing both from in EPDM and within SolidWorks when we use lightweight. I mean, you end up having to rebuild a lot more when you're working with lightweight than if you just open everything resolved from the beginning. In context design, that's another thing we kind of stress out. We do a lot of in context design at the design stage, but our requirement or our guideline is to break all the references once the design's done. I mean, that's just us because we have discovered a lot of issues, especially with performance. When you have those in context or circular references, it's a big issue.
At what stage of the process are you breaking the references? Because a lot of the pain is during the design phase. So.
Well, when it's ready for production. I mean, we have a design stage that's between a day and a week, let's say, for one of our, something that would be designed in context. After they have all their drawings that are production ready and they're ready to move it in our workflow, let's say the designer says it's ready, before they send it out to production, they have to break all the references.
So you're breaking it after you're doing the drawing?
Yeah, I mean, yeah. Yes?
What if you have to go in and wrap it up after your production?
I mean, we do the changes. I mean, we don't want to keep that design in context. I mean, you can modify a couple of parts that are not designed in context, no problem, in a few minutes. So there's a lot more to be lost if you keep them just in case than if you just go back and rework two parts, even though they're not still connected. Yes?
Some of the issues that you found with lightweight and compact design, did you ever get SolidWorks support involved or get an SPR number or anything like that?
I mean, we didn't find them to be bugs, just kind of work process as far as our environment. I mean, we ended up having decent hardware, decent workstations, so that we were not kind of forced into using lightweight. I mean, we came up with other workarounds, but we never kind of dug into it. Another big don't, flexible sub-assemblies. I mean, you can at one point open or set one to flexible and then kind of do what you need to do, but don't keep them flexible throughout the life of this project or this large assembly, because that's kind of having two live assemblies open. And I've seen cases where they have multiple levels of flexible sub-assemblies, and that just kills your session. Probably you're just waiting for a crash at any time if you do go more than one level being flexible.
Do you guys model routings at all, or hydraulics or airlines?
Yes, we do at the machine level, yeah.
Sorry if I'm backing up a little bit, but when you're saying to defeature a part, we've tried the same thing, savings of part, complicated assemblies. How do you manage the link between keeping the part linked to the assembly to the drawing?
That's part of our engineering workflow. Whenever there's a revision, the part of the process getting it to release is updating all of those files. Because every top level of our machines has a block part. So part of the process of the revision process is to update those block files. And a lot of changes don't require an update on that block. I mean, like if it's a specification of the motor or maybe a minor change on the overall that doesn't affect the overall design or how we interface with that machine, a lot of times we don't update it, but we do keep track of those changes.
So you keep that at the assembly level. In other words, if you go to that part,
Mm-hmm.
the top level assembly, there's no physical link to the assembly. You have to just go look it up.
Yeah, exactly. Well, you have the part number.
So it's completely separate.
Yeah, because we use a lot of the same blocks. Like I said, our product is kind of configurable. So we have blocks that represent multiple part numbers. Because maybe you have machines that just have different specifications for the motor. But we don't create a block for each machine. We just kind of use one block for the geometry that's going to match that.
At the top level assembly that you showed us earlier,
Mm-hmm.
how many actual parts are in that? And I imagine they're very large lumps, single parts.
I'll show you. Oh, this is still rebuilding. Yeah, that's what I said before. Before most of you guys got here, I said, welcome to the support group for large assemblies. Just kind of just venting out. I mean, but this is common. That's actually one of my frustrations is a lot of times we don't even know why it starts rebuilding. Even with suspend automatic rebuild on, it's like you do something and then boom, I'm rebuilding. It's like, we really didn't tell you to rebuild, but okay. Okay, so talking more about saving as parts. So who in here is saving their product or their established product as part files? Show of hands. So not a lot. That's actually very surprising.
We can't. Our PLM system won't allow it. It won't create the bill of materials if we save it as a part.
Well, in that regard,
PLM software generates the bill of material from the model structure. And if the model structure is not there, it can't automatically generate the bill of material.
even if you give that part file the same part number as the assembly?
It won't let you do that.
Okay, so that's a separate topic.
That's the
Yeah, no, that's more a procedural. Like I said, not everything's gonna apply to your environment because.
No, I know. I've been through this extensively, just like you have.
So the key, the key here is to not just save as a part. I know a lot of people say, oh, whenever I save my assembly as a part, it actually makes it worse. Well, it actually does. So there's a art behind it. That's kind of the title for this slide. So we're going to run a sample scenario of a total number of components. This is one of our machines. It's just about 5,200 components. That's it right there. Do you guys notice any difference between the left and the right? I mean, there's not much difference. That's kind of why I'm asking.
Did you modify the part file after you saved it? Did all the extra features you don't need?
Well, I mean, it's actually before. I'm sorry. Your question is,
You suppress components of the assembly.
did we go back to the part and simplify it? It's kind of both. You have to do a little bit of everything. So just some numbers. The top level assembly, the real assembly for this machine or this product is 40 megabytes. The actual memory loaded when it's open, it's almost 200 megabytes. So that's all the components loaded in SolidWorks. That's about 200 megabytes. So the first one, the one on the left, that was just the assembly save as a part. And you can see right away that those numbers are pretty similar. The part file and the total number of components in SolidWorks, it's about 200 megabytes. So that's kind of when you start running into problems. When you save assemblies as parts and you don't do your housekeeping, you're going to run into trouble. The part file on the right that you saw, that's only 5.5 megabytes. So that's a drastic change in regards to performance. You can see also total number of bodies, 2,700 versus 300. This column right here, graphic strangles. Is anybody here familiar with graphic strangles in SolidWorks?
Yeah, where are you picking that up, the graphic strangles?
I'll show you guys. And then the big item also, I mean, all of these columns kind of is what impacts your performance. And when you're dealing with over 10, 20,000 components, this is kind of where you get your performance benefits. 33 seconds versus 0.2 seconds rebuild time. A comparison of that same assembly, save at different stages of the simplification. The control, that's just assemblies, right, save as part. That's the one you saw, 187 megabytes. And then we said save as part, but before we hide all the hardware. So that saves about 20 megabytes. And then if you hide all the hardware and then hide internal components, you cut another about 40 megabytes. And then if you go in before saving as part and the feature or simplify, or maybe some of your components already have simplified configurations, if you turn those on, that's the biggest improvement. I mean, you see the file size go from 137 to 17 just by, I mean, getting rid of chamfers, some cuts, filling some holes. That's the biggest improvement. And then furthermore, if we get rid of more detail that's not shown, it doesn't affect how that machine is going to interface with the system or with your top level. You pretty much cut that in half. And then this is just kind of more in detail, remove more holes. If you freeze that, you use the freeze drag bar, that new functionality for 2013, you cut that down. And then the last one, you just delete all the history on the appearance property manager. Yes?
When you build your original parts, do you group in folders the features that you might remove or delete later?
No.
So you could do that, right? Like if you had chamfers and holes that you know are probably going to come out when you're building the original, say a sheet metal part, you could have all those at the end of your tree, or group.
I wouldn't recommend that, just because the intention of that part is not to be simplified. The intention of that part is to be manufactured. So I would focus more my modeling at the part level towards whatever benefit you get on the manufacturing.
It's like 2 different ways of working. One, you know, when you're working on parts, you just use your traditional methods, but then this is a whole other kind of vocation, right?
Yeah, I mean, that's why we say we have kind of the engineering side of it, where we design and build the machines, and then where we manage the projects.
Okay.
So they're kind of two separate fields in the world of SolidWorks.
Right. Let's say you've got your big pieces of equipment, and then you've got the pieces that have to be designed in the context of where those big pieces are located.
Mm-hmm.
How are you doing that in this method? Are you just measuring connection points and mapping it out? Like a conveyor belt between two massive pieces of equipment. You have to design the conveyor belt for the inlet and outlet of those other pieces of equipment.
Yeah, we have simplified blocks that we do for that layout purpose that have that degree of freedom where you can drag and stretch and say, but then the specifications that you end up with for that conveyor, you put that into the real assembly. And then, yeah, so you have a semi-done version that has, I mean, it's not just a block, you can actually move around it. And then once you're done with the final assembly of it, you save that as a part, and then you replace kind of the cells block, we call it, which has some intelligence to it, but it's still a part file. Yes?
The comparison between hidden and suppressed?
Yes, there's a difference. Can you build more context into that question?
Well, you said hidden internal components. If you suppress those internal components, they're just hidden.
Well, that's before you save it as a part, so it doesn't matter. Hidden is faster, so we just hide the components. We're going to save that assembly as a part after you're done with that process. So if you suppress them, you're going to take longer while it suppresses and rebuilds. So there's no real need to suppress them. You can just hide them, and when you save as a part, just make sure you say don't include hidden components. Yes?
How do you manage remembering that you did the save as part? Let's say 1 year later on, someone is using your assembly as part already, and you have to change it. drastic change.
Yeah, we keep the part number attached to those blocks. So we don't like in EPDM you could link it as a reference. We don't do that because we have a separate library of block parts. So everybody in engineering knows if they want to put a machine under layout or under project, they go to the block. They don't go to the real assembly. Yes.
How many blocks do you have per machine, say the size of that conveyor? How many different blocks do you have without one single machine?
We just have one.
I thought you said you've got like one that's kind of simplified, you can stretch it, you've got another one that's...
Oh, that's the sales block. For that machine, we don't... It doesn't change a lot. You pretty much the only thing will change would be the drive position. So that's configured into that sales model. So yeah, we do have a sales model and a simplified model of the real product. So that would be two. The answer.
Get off track.
Yeah. So I'll move on. So let me show you back to the graphic strangle. Oops. So a lot of files here.
On the desktop.
Time. Got 20 minutes.
We need more time.
Sorry about this. All this extracts. Let's move on. So the next big thing, like we were asking earlier, performance relief, abstinence. You guys need to stop mating. I mean, it all comes down to rebuild time. Every time you add a mate, I don't know if you guys are familiar with the way SolidWorks resolves or calculates the mates. It's not in a linear fashion, or it's not in a. It's a sort of matrix where every mate is kind of linked to the next one in one way or another. I mean, that's a separate topic for a separate presentation, but ultimately, the way we work, it's based out on an origin or a grid system. So whenever we create an assembly that's going to be assigned to somebody or serve a purpose on the project, it's pre-created in the top level or the assembly level so that you don't need to have any mates constraining it. So I'll show you an example of what I'm talking about. Okay.
Just have to kill it.
Let me just kill this.
Probably.
Yeah. I'm not a project engineer, so I just tell them how to do it.
Might as well show the graphics drawings too.
Yeah, I'll do that here. Where's this? Oh, that's on the J. Oops. Okay. So let's let load up. Any further more questions while this loads?
So when you have that assembly saved out as a part,
Mm-hmm.
do you drive a bomb off of it?
No.
So you drive a bomb off the assembly?
Well, the part number drives the BOM. So if we match the part number of the real assembly, and if you want to pull a BOM based of your layout, you just call out the part number of the real assembly. So SolidWorks doesn't care if it's an assembly or a part. Your PLM would, but SolidWorks, you can pull a BOM that says this is this machine and this is the part number for it. So whenever you release that BOM to production, it's going to grab that part number. It doesn't know if it's a part or an assembly. Yes?
So you're saying that to fix stuff instead of mating them.
Yep.
Say that you have 30 conveyors in an assembly, and you have an origin made for each of those conveyors. What is the load time compared to when you fix them? You don't have any mates in it whatsoever. Everything seems just fixed. What's the load time when you have them origin mated? I'm just curious.
You'd have to run the benchmark.
Yeah, you have to run a specific benchmark for that scenario. I wouldn't tell you what's the relationship, like each mate versus no mates.
I would disagree with that. So I do agree. Failed mates and incomplete parts that are not fully mated do take performance hit. But I just about guarantee you every application engineer in this building will not tell you to just fix all the parts. If that works for y'all, that's good. We can't see.
So what I found is that rebuild time can be affected by the degrees of freedom in your model. So if you do fix the part, it will open a little faster. On the flip side of that, yeah, coincident and concentric mates will remove some degrees of freedom, so that helps. But the highest impact mates that I've seen are things like width mates that really kill your file open.
Okay, so back to the graphics strangle. This is an option on the assembly visualization. So it's not here by default, but if you go to more, when you're in the assembly visualization, on the properties, you'll find it here, graphic strangles. So what this shows you is like pretty much how complex that part or assembly or whatever. If you have an assembly in here, you can collapse it or you can look at part by part. So in here you can see we have 105, almost 106,000 graphic strangles for this. This is the 5 megabyte file. And for the one that's 197 megabytes, that is 1,373,000 graphic strangles. So that will affect your performance. Even though right now, you don't see a lot of impact, but when you have 100 of those or more, and you have a lot of unnecessary detail or complexity, that's when the graphic strangles comes into play. And it's an awesome way to troubleshoot your assemblies. Just run the graphic strangle on your top level, and anything over 500,000, you probably need to look at it.
And the options to save an assembly as part of you looked at the difference between save as faces or save as bodies?
I would definitely save as bodies. Don't try to stay away from surfaces, especially for drawings.
Well, I wouldn't use the part for the drawing anyway, but I'm just curious as far as speed. Those are big difference.
I don't know. I wouldn't stay away from surfaces.
We've seen the surfaces carry a much higher load, especially if there's any sort of curvature to it.
So I'm going to use this as an example. Let's say this is my top level. I have 2 machines here, and I need to build something that's going to connect those 2 machines. So the way we do it to stay away from having mates, let's do it from here. If I say new assembly, I'm going to use this template, and then you can just fix this. So now this assembly has the same origin as the top level. So anything you put in that assembly is going to be, let's say I make a copy of this guy. Let's edit. Just bring something in. Quick block. Give it 15 minutes. We're good.
You should people delete that other block. That's killing your performance.
Go back to the slide. We don't use coordinate mates. I'm actually not familiar with them.
Okay, so typically what we do is if we're doing a large assembly like a water park where we may have 20 of those things, we create a simplified view. We have one coordinate mate, and then we do is a layout sketch. An overlay is usually the AutoCAD drawing of where in the part you're going to put it.
Mm-hmm.
And then you can mate your individual components or assemblies or simplified assemblies in the context of the part, not sucking down a large assembly. Might want to try that.
Well, it's kind of the same principle. We just, I mean, we don't see the need for it. This is working for us.
Yeah, in our particular case, because we're on an actual an overlay of a site, we actually need coordinates so that we can actually mount both predefine and mount all the
Yeah.
poles and everything else. So we can't just say, so be it for other people that may help.
Okay, so while the other assembly loads move on, system options, I mean, there's really not a lot there that you guys would have great benefit from. The basic ones on the system options, performance, the level of detail, go with less, of course, and then do not load components lightweight, again, because that, whenever you start working on that top level, if for any reason SolidWorks thinks you need one of the lightweight components, it will rebuild. So you're kind of shooting yourself in the foot if you load everything lightweight and then just as you're working, everything starts rebuilding. So just kind of the way we see it, do the rebuilding up front, let it open, take, I don't know, 10, 20 minutes, and then you can work on it without having to pause as often. On document properties, image quality is definitely look after that, especially if you have multiple users. A lot of users will tend to bump up the image quality to kind of have a nicer looking assembly or part, but that kills your performance at your top level. So you can actually go in there and set it to low and apply it to all reference documents.
And that would go through everything below that?
Yeah, that will kind of inherit to everything. Just that's why it's called document. It's on the document properties. It's specific for that document.
There's a change in 2014. I think you said you didn't test 2014.
Yes, we haven't.
If you use large design review or large assembly mode, I understand why you said don't use large assembly mode. That's fine. SolidWorks now has a optimization so that they can actually display large assemblies much faster.
Okay.
So you might see up to 2x performance improvement for not 60,000 components, but smaller things you might see it even better.
Yeah. All right.
So it's okay to keep these settings, but you might find actually a very good performance improvement just by going to 2014.
That's good.
You also turn off all those animated zooms and stuff like that that chews up graphics.
Yeah, I mean I mean we assume that was understood. So drawings. I know a lot of, yes, sorry.
Just real quick off topic, you prevented an accident, maybe I missed this earlier, you talked about that fixing components and then assembly.
Mm-hmm.
Do you provide, or do you put in mates to those components first and then fix it?
Yes, use for positioning.
For some instances we do the option that's called use for positioning only. So a lot of times we'll place it using mates, but then we'll just kind of fix it after it's in its place. The method I'm going to show you guys before we get out of here. Okay. So what I did is I created this assembly in context of this assembly, of this top level assembly. I placed two conveyors for some reason. If I X out of this, I mean, you see those conveyors are not where they need to be. but the origin, both origins are in the same place. So if this is an assignment for somebody in my team, I can just tell them to work on this assembly 1, and anything they do in that assembly 1 is automatically going to start showing up on my top level. So that's kind of the way we have a structure our work breakdown, where the project engineer pre-creates all those assemblies and assigns them to the designers, and then they can open the top level and they can work in context or independently of the top level, but all their work is going to start showing up at the top level where in the place it needs to be. So it's kind of like in place made, but instead of creating the made, the first thing we do is fix this. So this is not going anywhere. No matter what you do, if we open it.
You get a lot of your users complaining that when you do a zoom all, they get their geometry that ends up being very small when they're working out towards the.
No, I mean that has happened. Usually some sort of geometry out there, some sketch point or a little piece of hardware, a washer, or somebody just accidentally dropped out in the middle of nowhere. So no, to answer your question, not necessarily. So kind of building more on this, let's say if they start messing with this, and then they move some stuff around, and they say, you know what, this is not supposed to be here. It's more like that. And then I just...
Custom tool you got shown there?
That's for another time.
That's a different presentation. That's next year's presentation. Okay, so you saw, I mean, the top level updates, and you don't need to be worried about it being where it's not supposed to. I mean, it's fixed here. So all your work would be either done at that level, or you could do it in context of this level without affecting your constraints. There's no constraints. And that's what's given us the biggest performance as far as, or not just performance, but overall stability of our extra large assemblies is not having mates.
Do you find that it crashes less frequently?
Oh yeah, because it's not really doing anything at the top level. So when you're working on it, it's not calculating, or it's calculating very little things. Yes?
Have you ever evaluated constraining origin to origin?
We don't see the need to, because I mean, you kind of create it in place, so the origin is in the place of the origin.
It's in the place, yeah. It's just then it's constrained, and you know how it's going to react when you move things as opposed to fixed. It's just kind of fixed.
I mean,
you don't have to.
Our origin wouldn't change, so we don't see the need to do that. But yeah, I see your point. It's kind of the same thing, constraining origin to origin and apply to all degrees of freedom. Yes?
You mentioned breaking external references.
Mm-hmm.
How does that compare to locking?
Oh, that's just as good.
It works. I mean, we just break them because we rarely come back and modify things. Any more questions on this? Okay, so drawings-wise, we have a hard time creating drawings as well, as most of you probably, for these massive assemblies. So what we have resorted to is SolidWorks Composer. Now most of our content that we need to put out there for customers, for approval, for installation, and some manufacturing, we use Composer to communicate. So this is a sample executable file you can publish from Composer. So the first slide just has some instructions on how to navigate. So we send this out. And then you can just navigate through the views. So if we send this out to the customer, we have our last page is kind of their customer approval page. So this at all times is the 3D model. You can get some feedback from your bill of materials or your equipment listing. We just try to put everything we would put on a drawing, we put it in the 3D. And they get this and they I mean, they can measure, they can print this, sign it off, and send it back to us. So
So you use that like a general arrangement drawing?
yes, this will be their drawing, because in order for us to create a SolidWorks drawing with this level of detail, we need to spend a couple of weeks. This takes about 4 hours to do. So as long as the customers are not complaining or whoever gets it, that's what I would recommend you guys try. If you need to, I don't know, communicate or collaborate with outside people, Composer is a really good option.
We actually use it for our shop floor. We don't issue drawings to the shop floor. We issue Composer files just like this. Does your company actually build, or you just issue to the customer?
No, we manufacture everything we design. So yeah, I mean, we don't use it for, we're trying to go that route, but not yet. But
I can tell you the big problem is we're stuck, we build boats,
Mhm.
and we're stuck to workstations on the floor that they can access this information. So when they go up into the boat, they've already forgotten everything in it. So the big hang up for us is a tablet version of Layer.
yeah, I mean, that's something I'm looking at right now with hardware solutions or virtualization with the NVIDIA grid or any other solution that kind of enable us to interface with people outside of the office.
Is that an automated process going from SolidWorks to 3D Composer?
That was just what I was going to ask. Do you guys use Sync, or do you take the top level manual? SolidWorks.
We just save it or export it to Composer and then work there. And then if there's any updates, you can update the model in Composer.
Are you using projects or SMGs only?
We use both.
So you do projects and then feed them in
It,
single SMG?
it depends, yeah.
So it's a manual push from SolidWorks to Composer for you guys right now.
Yeah, it's not parametric.
And are you guys managing your Composer data in EPDM?
And we just started doing this, so I would say yes, we will start managing it in Composer.
Here's another question.
I mean,
about
EPDM.
Composer. Are you producing the Composer file after everything's done?
No. I mean, there's different scenarios. A lot of times, depending on the need of that project or the purpose of that file, we do different stages.
The challenge we've been facing is there's stuff in the model that's in process of engineering and stuff that's finished, and distinguishing that in the Composer. We've just been manually coloring everything that's in process.
Yeah, that's more a procedure, internal procedure kind of thing. So that's it for today. We got it right down on time. If you guys have any questions, I have business cards here. I can stay around and answer questions. I just move out of here, so next presenter. And thank you for coming.